So solving systems by substitution takes a little more work than graphing, but sometimes it's easier to do substitution than it is to graph, because graphing can take a long time, or maybe the points aren't going to intersect on a normal graph. They might be at really big numbers. So substitution allows us to look at and say, okay, how do I do this without a graph? So I kind of have some steps I'm going to work through, right? First one is to get one of the equations, right? Doesn't matter which one, equal to one of the variables, right? Again, it doesn't matter what equation you're using, what variable you're using. We'll talk about how sometimes things make more sense to do one variable or the other. And then I'm going to take whatever expression I get there and plug it into the variable into the second equation, right? So basically whatever one I didn't use, I'm going to plug in. Then I'll have an equation that I can solve, all right? And then I'm going to plug that solution into from step 3 into one of the original equations and solve for the remaining variable. And then I just want to make sure that I check. All right, so if I look at kind of these examples, if you look here, I notice that I already have y equals 3x, right? So step 1's kind of done. So now I want to take this 3x and I want to plug it right there for y, right? Those things are equal. So I can say that x plus 3x equals negative 32. And now I can solve this, right? So 4x equals negative 32. Divide by 4. X is negative 8. So now if I want to find my other variable, right? Y equals 3 times negative 8. Just plug that in, kind of back to evaluating expressions. And so I get y is equal to negative 24. And so my point would be negative 8, negative 24. Right? And so we know that if I were to graph that, right, I'd have to go on a very big graph to find that point. So this is why substitution sometimes makes some more sense. So if I want to check that, right, I already know I did 3 times negative 8 to get negative 24, so I'm good. And I want to say, is negative 8 and negative 24? If I add those together, do I get negative 32? Answer is yes, so I'm good to go. Right? So if you look at the second example, all right, I don't have any y equals or x equals. So the question is, how do I get one? I could solve the top one for y or x, right? But if I notice, right here, I have a y, one y by itself. So I can add 2x to both sides and say, well, y equals 2x minus 3. Now I have an equation that I can do. So I'm going to take this y equals 2x minus 3, and I'm going to go back to the first one that I didn't use and plug that in. So I can say that 3 times 2x minus 3 plus 4x equals 14. So now I have an equation that I can solve. All right, so distribute that. So we have 6x minus 9 plus 4x equals 14. And so I just keep solving that like we've been doing for quite a while. So 10x minus 9 equals 14. So when I add 9, I end up with 10x equals 23. And so x equals 2.3. And so I just want to go back up to one of the original ones and say, if I have negative 2 times, oops, that should have been 0.3. Negative 2 times 2.3 plus y equals negative 3. And I solve that. So I have negative 4.6 plus y equals negative 3. Add that, I get y is equal to 1.6. Right? So just for the sake of time, I'm not going to go through and check that. I think you guys have a pretty good handle on how to do that. So I get the next two examples, right? I look, great, I have x equals, right? So I can take what that x equals, right, and plug it in right there. So it works the same way if it's x equals versus y equals. So I can say, well, 3.5 times negative 2y plus 4 plus 7y equals 14. And so I work on solving this, right? So negative 7y plus 3.5 times that would be 12, 14 plus 7y equals 14. And so when I combine like terms, right, I end up with 14 equals 14. So my variable is gone. And so when I look at this, right, I say, well, my variable is gone, right? What does that mean, right? Well, it means I can put in any value for y that I want and get an answer, right? So this one is going to be an infinitely many solutions, right? So anytime you get an equation that's just numbers and it's a true equation, you can say infinitely many solutions. So look at the next one, right? I have y equals here. So I'm going to take that 3x minus 11, just plug it in right for y. So I say 3x minus 11 minus 3x equals negative 13. And so these kind of cancel, and I get negative 11 equals negative 13. So I say there I have the numbers, but that's not a true equation, right? Negative 11 does not equal negative 13. So what that means is that no matter what variable I put in, I'm never going to get an answer, right? So this one, anytime that happens, is a no solution.